So let's take a look at finding arc length. So the formula for finding arc length is pretty basic, as the arc length is equal to the integral from a to b of the square root of 1 plus f prime of x, or the derivative of f, squared dx. And that's if you're using x coordinates and putting everything in terms of x. Now if you're using y coordinates and putting everything in terms of y, you just need to be able to switch the variable. So we're still going from a to b, the square root of 1 plus f prime of y squared dy. So the first problem asks to set up the integral for the arc length of y equals the square root of x plus 2 with the bounds going from 1 to 7. So we already know that it's asking for x bounds, so we have to put everything most likely in terms of x. So let me write the formula once again. So the arc length is equal to the integral from a to b of the square root of 1 plus f prime of x squared dx. So there are two things we need to find here. We need to find our bounds, and we need to find what f prime of x equals. And we already know what our bounds are. We're going from 1 to 7. So what's left is finding what f prime of x equals. We already know what f of x equals. It's the square root of x plus 2. So in order to find f prime of x, all I need to do is derive it. So I'll write y equals the square root of x plus 2. So y prime, or the derivative of the square root of x plus 2. So if I were to rewrite x plus 2 down here, just rewrite it as x plus 2 to the 1/2 power. So now I can use the chain rule. So y prime would equal 1/2 times x plus 2 to the negative 1/2 times the derivative of the inside function, but the derivative of x plus 2 is just 1. So y prime will equal, I can simplify this by moving the exponent down. So I would get 1 over 2 times x plus 2 to the 1/2, or the square root of x plus 2. So if I were to rewrite the arc length equation, I'll say the integral from a to b, so our lower bound is from 1 and our upper bound is to 7. So we're going from 1 to 7. Of the square root of 1 plus f prime of x, and f prime of x is equal to 1 over 2 times x plus 2 to the 1/2, or I can write the square root of x plus 2 squared, the entire thing squared, dx. Now I'm not going to antiderive this by hand since it's just asked to set up the integral, but this will be what you plug into your calculator to get the correct answer. So the second question asks to determine the arc length of x equals 4 times 3 plus y squared from the y bounds of 1 to 4. So notice that it is giving the y bounds, so we must have to put everything in terms of y. So once again, I'll rewrite the arc length formula. So from a to b of the square root of 1 plus f prime of, in this case we're putting everything in terms of y, so I'll just put f prime of y squared dy. So once again we have our y bounds of 1 to 4. Now we just need to find what f prime of y equals. So we have our formula, or our x equals 4 times 3 plus y squared. So I'll just write that here. So now we need to find what x prime equals, or the derivative of x. So x prime, once again we're going to have to use a chain rule. So we bring the 2 down. So we have 4 times 2 is 8 times 3 plus y. And we can subtract the power by 1. So 2 minus 1 is 1. Multiplied by the derivative of the inside function, and the derivative of 3 plus y is just 1. So x prime is going to be equal to 8 times 3 plus y. So if I were to rewrite the arc length formula here, we get the integral from a to b, and this time our bounds are from 1 to 4. So from 1 to 4, the square root of 1 plus f prime of y, and that is equal to 8 plus, or 8 times 3 plus y. Squared dy. If I wanted to simplify this even further, I could just square the 8 plus 3 times y, or 8 times 3 plus y, sorry. Get the integral from 1 to 4, the square root of 1 plus 64 times 3 plus y squared dy. And that is the final answer for the arc length formula.